some of you may not have taken your statistics courses, and you can really struggle with this chapter if you do not have that foundation. So in order to clarify what is being explained in terms of variation and standard deviation, we will review example 8.2. Now, for those of you who have already taken statistics, this may be a bit of a review. So first of all, let's look at variation and standard deviation as a concept. Even if we calculate the numbers, it's not really going to do us a lot of good if we don't know what the numbers mean. So let's look at this diagram. And this is a standard normal distribution curve. Now, if the center line is the average, where we record our average, and that's the mu, that's the symbol for average, then each vertical line is a deviation from the mean. Okay, and that's a standard deviation. And you have them on the positive side, or the right side of the curve, as well as the negative. Statistically speaking, 68% of your data, 68.3% of your data will fall within one standard deviation of the mean. This is your average. This is one standard deviation to the negative side and one standard deviation to the positive. Okay, then 95.4% of your data will fall within two standard deviations. And then 99.7% of your data will fall within three standard deviations. And this is important to understand, because if you have data results that are beyond the third standard deviation, you might decide to investigate these results because they're so unusual, say in a quality failure. Or you might decide to ignore these results because they occur at such a low percentage. Either way, the standard deviation gives you a way of looking at the data and seeing if it is falling within the expected ranges. So now we're going to look at example 8.2 on page 218. Now you should read the steps on page 218. There's a whole set of steps here. You look up here at the top. It's not very clear on the video, but you should be using your book with this as well. So you have these steps here that you should memorize. But if you tend to do better with pictures or processes, then you may decide you just want to memorize the header row of this table. Either way, you're memorizing the process of calculating a variance and a standard deviation. And since you will use this information again in your statistics courses, I would not put off learning it. So we're going to go through this quickly at first as a basic review, and then we're going to start the process over and go through it in detail for those who still need additional assistance. Okay, so in table 218, the first column is the year, and if you're going to memorize the header row, I would change that description from year to description, or change that title from year to description. The first actually important row or column is your observation column, and this column lists all the data you'll be working with, and when you list all the data, then you add it together at the bottom and calculate the average. And in this example, the total value of the observations, 158.74, and then the average of that is 15.87. And the second column is where you will apply your averages to your data. So in each row, you will see the average is 15.87. Now in the third column, you will subtract the average from the actual return, and that will give you the number in the difference column. Now this is where it can get a little tricky. You're going to square this difference. Why? Well, we don't want to be working with negative numbers, and if we square them, then we get rid of the negative numbers. We then add them all together. So we have negative 42.95 squared equals 1,844.70. We do this with each line. And then we add the answers together, and that gives us the sum of the squared differences. Now to calculate the variance, you can see this on the last line of the table, we divide the sum of the squared differences, which is the 4,269.46. We divide that by 9. And you'll see here that the n, or the 10 minus 1, this is the number of observations minus 1, allows us to divide this by 9. And the answer of 474.38 is our variance. And the symbol for variance is alpha squared. 474.38. And then when we take the square root of the variance, that's when we get our standard deviation of 21.78. Now if you look back at the observation, now let me leave this here so we can go over this. Each one of these standard deviations has a value of 21.78. So this is 21.78 points higher than the mean. Then we add another 21.78 to get the second, and another 21.78 to get the third value. And when you add this together, you get 81.21 and a range of negative 49.47. And if you look back at the data, you will see that we have no observations outside of that range between 49.47 and 81.21. Now for those students who have had statistics and this video has reminded you of what we're doing here, you may want to stop the video. For those of you who are still struggling with the concept, we're going to start over from scratch and go over the complete process in greater detail. So here we go in greater detail. Okay, so let's go back here, page 218. The first column in this case is just a descriptor. It's just telling us the title for the data that we're collecting, and in this case we're using years. Sometimes you may not even use a descriptor column, you just might use data. For this analysis we will use year. So in the first column, and I'm going to build this up from scratch because I think if you see it actually worked out, then it'll make a little more sense to you rather than just reading through the table. So in the first column, we write down each of the years. We're starting with 1990, 1991, 1992, 1993, 1994, 1995, all the way to 1999. And this is a period of 10 years. So our n is 10 in this case. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me move this over so we can get a little clearer vision. There we go. Move it up and over. Hey, it's harder than it looks, all right? Okay, so in this second column, we're going to write down the actual returns. And in this case, this is our data that's being collected, okay? So in 1990, the return on these small company stocks was negative 27.08, then 50.24, 27.84, and you'll see we're just going basically down the table, reciting the returns. This negative 27.08 is a loss. So then we have negative 3.34 for 1994. That's also a loss. 33.21, 16.50, 22.36, negative 2.55, another loss, and then in 1999, finally 21.26. Now we need the average of this column because we will be using it in the next column. So we add all these numbers together and we get 158.74. And to get the average, since we're evaluating 10 years, we have divide that by 10, and we get our average of 15.87, and that is the value that we're going to use in the next column. And you also see that in the textbook. So each one is going to be compared against the average. I know this seems a little bit redundant, but we're doing this because I want you to see in each case how we're getting that table set up. Okay, because you're going to have to do an evaluation yourself. Now in the next column, we are subtracting the average from the return. Okay, and that's another reason why I wanted to put the average, so you can actually see that we're subtracting this. So this column, we are subtracting from the return the average. Okay. All right, we'll bring this down. Okay. Make sure we can see everything. Get this all under the camera. Okay, so we're going to take the 1587 and we're going to subtract it from negative 2708. So we take negative 27.08 and we subtract 1587, and that is negative 42.95. Now, I need to caution you on this. For those of you who are good in math, this might not give you a problem, but for those of you who struggle, then we need to talk about this just briefly. When you subtract something from a negative number, when you write it down, you're saying negative 27.08 minus 1587. Okay. Now what you're actually doing here, and I'm sure you'll remember this from your math class, you are actually adding the opposite. So you're adding negative 1587. And when you add two negative numbers, you add them together and you take take the symbol. These are both negative numbers, so your answer is going to be negative. So when you add those together, you get a negative of 42.95. Okay, so that's how we arrive at that number. I just want to point that out. And actually, you can't see it from your vision on the screen. So let me go over this one more time. I'll put it right over here. All right, so we have a negative 27.08. All right, and you are subtracting from that 1587. All right. But what you're really doing from a math standpoint is you're taking the negative 2708 and you are actually, you are actually adding, when you subtract 1587, you are actually adding the opposite, and that's a plus negative. Okay, so you've changed that to a plus. So now you're adding these two numbers together, and that gives you the negative 42.95. Okay, so just want to bring that to your attention because we're going to see this a couple of times. Okay, so now we're going to take 50.24 and minus 15, subtract 1587 from it. That's going to give us 34.37, and we're going to go down the row, go to each row, and subtract our average return from our actual return. Okay. We have another negative here. This is a loss, and we're going to subtract 1587 from that, which is going to give us a negative 1921. Okay. 33.21 minus 1587. That gives us 17.34. And we can line these differences up right with what's going on in the table in the book. Again, another negative, so you're going to enter 2.55 as a negative number, hit the subtraction, and then 1587, and that's going to give you negative 1842. All right, 2126 minus 1587, 5.39. Okay, Now, just to keep the page cleaned up, we're going to go to this next column. Draw a line right here. Okay. Now, the next thing we're going to do is we are going to square this difference. And the reason why we're squaring it is because we do not want to be working with negative numbers. This is the average. And we're going to square what we came up with in this column. All right, so the way we do that, we take the 4295. Okay, you see that in your calculator. Okay, you're going to hit the plus minus key. That's down here on the bottom, this key right here. Okay, you're going to hit the plus minus key, and then you're going to hit the x squared key right here, which is x squared, and that's going to give you 1844.70, which is the answer in the far right column in the example in the book. And so we're going to continue to do this. 3437, then hit the x square. Okay, that gives us 1181.29. Then we have 1197 squared. That gives us 143.28. 443 squared. That gives us 19.62. Then we have 1921. That's a negative number. We're going to square it to get rid of the negative number. We end up with 369.02. We're going to square 17.34 squared. That's 300.67. We had to bump that up to 68 since it's in the book. All right, 0.63 squared gives us 0.40, 0.3969 rounded up. 6.49 squared gives us 4212. Again, another negative number here. 18.42, hit the negative sign, hit the x squared button, you get 339.29. And then 5.39 squared, you get 2905. All right, and this gives us all our returns minus the averages squared so that we get rid of the negative numbers. And then we add all this together, we're going to end up with 4,269.46. Okay. All right, and this is, you'll see the sigma signal, the symbol. This is the sum of the differences of the squares of 4,269.46. Okay, we're going to go up a little further on this. Okay, now to calculate the variance in this example, we're going to take this 4,269.46 and we're going to divide it by 10 minus 1, which is shown on page 218, the last column in the variation calculation table. You'll see where it says, on the last page, it says 10 minus 1 on the denominator. Okay, so that'll be 9. So you'll divide that by 10 minus 1 is 9, and that gives you the variance of 474.38, and as we discussed in the last video, the symbol for that is alpha squared. When you take the square root of alpha squared, you get the standard deviation, and the standard deviation is 21.78. Okay, so what that is telling us in terms of our original design here is that each standard deviation of 2178 is one standard deviation. Each standard deviation has a value of 2178, which we'd already put here on our chart. So our outside, our highest range will be 81.21. Our lowest number in our range is negative 49.47. And this is how that table on page 218 falls within the normal distribution curve. So if you have any questions, let me know.